this episode, we look at different types of vulnerabilities and how they lead to risk-based decisions. A vulnerability is a weakness, but not every weakness looks the same, and not every weakness deserves the same response. Some vulnerabilities are in software code. Some come from configuration mistakes. Some live in identity systems, cloud permissions, or daily business processes. You need to recognize the type of weakness because the type often tells you how an attacker might use it, how easy it may be to exploit, and how urgently it should be fixed. A missing update on a public server is different from a weak approval process for changing bank account information. Both can create risk, but they create risk in different ways. When you understand vulnerability types, you stop thinking only in terms of severe or not severe. You start asking what could happen next, who could take advantage of it, and what action would reduce the most meaningful danger. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. Software vulnerabilities are weaknesses in applications, operating systems, libraries, firmware, or other code that systems depend on. They may come from programming mistakes, insecure design choices, outdated components, or unexpected interactions between parts of a system. A software flaw might allow an attacker to crash a service, bypass authentication, read information they should not see, or run code they should not be able to run. Some software vulnerabilities are easy to understand at a high level because they involve a program trusting input too much or failing to check something carefully. Others are deeply technical and require specialized knowledge to exploit. You do not need to know every programming detail to understand the security concern. The question is whether the vulnerable software is reachable, important, and useful to an attacker. A flaw in a public-facing application usually creates more immediate concern than the same flaw in a system that is isolated and closely controlled. Configuration vulnerabilities happen when a system, application, service, or device is set up in an unsafe way. The technology may be capable of being secure, but the settings create exposure. Examples include default passwords, unnecessary services left running, overly broad permissions, public access that should be private, weak logging, disabled security features, or remote access allowed from too many places. Configuration mistakes are common because modern systems have many settings, and some of those settings are not obvious. A cloud storage resource might be created quickly for a project and accidentally left open. A firewall rule might be added for testing and never removed. A service account might receive more access than it needs because broad access was easier during setup. These weaknesses can be attractive to attackers because they do not always require advanced techniques. Sometimes the door is not broken. It is simply left unlocked by mistake. Identity vulnerabilities involve the accounts, credentials, permissions, and trust relationships that control who can do what. Identity is a major part of modern security because so much access is based on proving who you are and what you are allowed to use. Weak passwords, reused passwords, stale accounts, shared accounts, missing multi-factor authentication, MFA, and excessive permissions can all create identity risk. A stale account is especially dangerous because it may belong to someone who left the organization, changed jobs, or no longer needs access. If an attacker finds or steals that account, the activity may not be noticed quickly. Excessive permissions create a different problem. A user may only need access to one small part of a system, but if the account has broad privileges, compromise of that account can become much more serious. Identity vulnerabilities are often high priority because attackers love valid access. It lets them blend in. Cloud vulnerabilities often come from the speed, flexibility, and complexity of cloud environments. Cloud services can be created quickly, connected easily, and exposed accidentally if permissions or network settings are wrong. A cloud vulnerability might involve public object storage, overly permissive identity roles, exposed management interfaces, weak secrets management, insecure application programming interface, API, access, or poor separation between environments. The cloud itself is not automatically insecure. The risk often comes from misunderstanding shared responsibility, moving too fast, or assuming that default settings match the organization's security needs. Cloud resources can also be difficult to track if many teams create services independently. A forgotten test environment can still contain real data or live credentials. Risk-based decisions in the cloud depend on visibility. You need to know what exists, who owns it, what it can access, and whether it is exposed beyond the people and systems that truly need it. Operational process vulnerabilities are weaknesses in how work is done. These can be just as damaging as technical flaws because attackers often target people, approvals, handoffs, and assumptions. A process vulnerability might exist when the help desk resets passwords without strong verification, when financial changes are approved through email alone, when new vendors are added without review, or when employees can bypass security steps to save time. These weaknesses may not appear in a vulnerability scanner, but they can create serious risk. Imagine an attacker impersonating an executive and convincing someone to change payment details. The weakness may not be a software bug. It may be a process that does not require independent confirmation for sensitive changes. Operational vulnerabilities remind you that security is not only about systems. It is also about how decisions are made, how exceptions are handled, and how people confirm that a request is legitimate. Different vulnerability types affect exploitability in different ways. Exploitability means how practical it is for a threat to use the weakness. A software vulnerability may require technical skill, a certain version, or a specific condition. A configuration vulnerability may be easier if it exposes a service directly to the internet. An identity vulnerability may become exploitable as soon as a password is stolen or guessed. A process vulnerability may be exploitable through persuasion, pressure, or confusion instead of code. When you evaluate exploitability, you are not asking whether harm is possible in theory. You are asking how realistic the path is. Can an outside attacker reach the weakness? Does the attacker need an account first? Does a user have to click something? Does the weakness require rare timing? The easier the path, the more urgency usually rises, especially when the affected asset is valuable. Risk-based decisions also depend on impact. Impact asks what happens if the vulnerability is used successfully. A software flaw that allows access to a test system with fake data may have limited impact. The same kind of flaw in a customer database may lead to privacy exposure, legal obligations, reputation damage, and recovery costs. A misconfigured internal dashboard might be low risk if it shows only harmless status information. It could be high risk if it reveals sensitive business data, security alerts, or credentials. An identity weakness in a normal user account matters, but the same weakness in an administrator account matters more. Impact is tied to data, business function, trust, safety, and dependency. When you connect vulnerability type to impact, you begin to see why security teams cannot prioritize by category alone. They need to understand what the weakness protects, supports, or exposes. Vulnerabilities can also combine in ways that increase risk. One weakness may not look disastrous by itself, but it can become serious when paired with another weakness. A public-facing application may have a moderate flaw, and the server may also have excessive permissions to a database. A user account may have a weak password, and MFA may be missing. A cloud storage container may be private, but a leaked access key may still allow entry. Attackers often think in chains. They look for one step that leads to another step, and then another. This is why risk-based decisions should consider attack paths, not only individual findings. A vulnerability that helps an attacker move from low-level access to sensitive systems can be more important than it first appears. The question becomes what the weakness enables, not only what the weakness is called. Remediation urgency is shaped by vulnerability type, exposure, exploitability, and impact together. Some issues need immediate action because they are easy to exploit, already being targeted, and tied to important systems. Other issues may be scheduled into normal maintenance because they are less exposed or less likely to cause major harm. Fixing a software vulnerability may involve applying an update. Fixing a configuration vulnerability may involve changing permissions, closing unnecessary access, or enabling security controls. Fixing an identity vulnerability may require disabling stale accounts, reducing privileges, or adding MFA. Fixing a process vulnerability may require changing approval steps, training staff, or adding verification for sensitive requests. Urgency does not always mean panic. It means choosing a response that matches the risk. The best action is the one that reduces the most meaningful danger without creating unnecessary disruption. Sometimes the right decision is not a permanent fix right away. A team may need a temporary mitigation while a full solution is planned. A mitigation reduces risk without completely removing the underlying weakness. For example, if a patch cannot be applied immediately because it might break a critical application, the organization might restrict access, increase monitoring, disable a vulnerable feature, or place additional controls around the system. If a cloud permission issue cannot be redesigned instantly, the team may remove public access first and then clean up the larger permission model later. If an operational process is weak, a temporary approval checkpoint may reduce risk until the process can be redesigned. This kind of thinking is practical. Security teams often have to balance urgency with stability. The goal is not to pretend the risk is gone. The goal is to reduce exposure while moving toward a stronger long-term fix. There are also situations where a vulnerability may be accepted for a time. Risk acceptance means the organization understands the risk and deliberately decides to live with it under defined conditions. This should not be confused with ignoring the issue. Ignoring means no one has taken responsibility. Accepting risk means the right people understand the weakness, the likely impact, the reason it is not being fixed now, and the conditions that would cause the decision to change. For example, an old internal application may have a known weakness, but it may be scheduled for replacement soon and protected by strict access controls until then. That decision might be reasonable if it is documented and reviewed. Risk acceptance should be limited, visible, and owned. It should not become a quiet dumping ground for problems no one wants to solve. Modern vulnerability management also requires ownership. Every weakness needs someone who can make or coordinate the fix. Software teams may own application code. Infrastructure teams may own servers and networks. Identity teams may own accounts and access policies. Cloud teams may own cloud architecture and permissions. Business leaders may own operational processes. Without ownership, vulnerabilities sit in reports and nothing changes. Ownership matters because risk-based decisions often require trade-offs. A security team can identify a dangerous configuration, but the system owner may need to test changes. A process weakness may require leadership approval because it changes how work is performed. A cloud permission problem may require several teams to coordinate. Security works better when vulnerability types are routed to the people who can actually reduce the risk. Finding a weakness is only the beginning. Assigning responsibility is what turns awareness into action. A helpful way to think about vulnerability types is to ask what kind of control failed or was missing. If the issue is outdated code, the answer may involve patching and software maintenance. If the issue is unsafe settings, the answer may involve configuration standards and review. If the issue is excessive access, the answer may involve least privilege and stronger identity governance. If the issue is cloud exposure, the answer may involve better asset inventory, permission design, and monitoring. If the issue is a business process gap, the answer may involve verification, separation of duties, and clearer approvals. This approach keeps you from treating every weakness the same way. It also helps you understand why a purely technical response is not always enough. Some vulnerabilities are fixed with updates. Others are fixed by changing how people, systems, and decisions interact. As you continue with Security Plus version 8 and SY0801, remember that vulnerability type is more than a label. It helps you understand how a weakness might be exploited, how serious the impact could be, and what kind of response makes sense. Software flaws, configuration mistakes, identity weaknesses, cloud exposures, and operational process gaps each create different paths for attackers and different responsibilities for defenders. Risk-based decision-making brings those details together. You consider likelihood, impact, exposure, exploitability, asset criticality, and available remediation options. That is how you move beyond simply saying something is vulnerable. You learn to explain why it matters, how urgent it is, who needs to act, and what action would reduce risk most effectively. Good security judgment comes from that connection between technical weakness and real-world consequence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.